Hello grade 12s, this is Mrs. Smith again, and we are now going to look at a second example of solving trig triangles with variables. This one just has a little bit more detail in it. So our second example, in the figure A, B and C are 3 points in the same horizontal plane. AD represents a lamp pole that is perpendicular to the horizontal plane. They have shown us that it's perpendicular. If they didn't, you would put that little block there so that you do not forget. It is further given that BDA and ABC is equal to theta. They have given that information on the diagram. BCA is equal to beta and BC is equal to x. Write BAC in terms of theta and beta. So we're not looking for the answer for angle BAC, but what we are looking for is some way to express this angle. And if we've got angles inside a triangle, we know they add up to 180 degrees. So therefore BAC is going to be 180 degrees minus the sum of the other two angles, which is minus theta plus beta. Okay, subtracting that whole thing using interior angles of a triangle. Make sure you don't forget that, so I'm going to squeeze it in here on the diagram. Next one, show that AB is equal to x sine beta sine theta plus beta. So we're looking for AB. AB is that line over there. We need to use the x, which is over here, and at this stage you should be able to see that we are going to be using this triangle because triangle ABC has the theta plus beta that we've just worked out. It's got beta and it has x. So let's have a look. In triangle ABC, we've got one side, 3 angles. Okay, so with 3 angles in a side, we've basically got enough information to use the sine rule. So I'm going to go AB over sine of the angle opposite, which is beta, is equal to x, because we need to use the x, over sine of the angle opposite, which is 180 degrees minus theta plus beta. Okay, we're going to multiply by sine beta because they've asked us to work out AB, so we have to get AB on its own. But we also look at what we're trying to prove. We don't want the 180 degrees there. So 180 degrees minus, that is a reduction rule. And remember that sine of 180 degrees minus an angle, that would put us in the second quadrant where sine is positive. So that would be sine of the angle. So that's actually exactly the same as what we've got in the denominator for the thing we need to prove. So I've got AB is equal to x sine beta by multiplying by sine beta. And then in the denominator, using my reduction rule, I'm just left with sine theta plus beta. Okay, the next question. If AB is equal to AC, show that AB is equal to x over 2 cos theta. So we're going to stay in the same triangle because I still need to do AB, I still need theta, and I still need x. So we're still going to stay in triangle ABC, using the same triangle, but this time I don't want to use the sine rule. Again, look at the question, and you notice the question has a cos in it. So which of our rules has cos in it? That would be our cosine rule. So using our cosine rule, I'm going to go to that diagram. I need to use the theta. So I need cos theta, and whichever angle you're going to use with the cos, you start with the side opposite. So I'm going to have AC squared is equal to AB squared plus x squared minus 2abx cos we can see now that we've got AC squared is equal to AB squared plus X squared minus 2ABX cos A. But remember, they've told us in this question that AB is equal to AC. So I can take that and substitute it in here, and I get AB squared is equal to AB squared plus X squared. And now we have to get AB on its own. So I'll start off by moving those two terms over to the left, and you notice that the AB squareds cancel out to give 0. And now I'm going to divide by the negative 2 and the x cos theta. So I have negative x squared over negative 2x cos theta is equal to AB. And now it's quite easy to see that the negatives will divide out. The x's will divide out, leaving an x on top and 2 cos theta at the bottom, which is what they have asked us to prove. The next question, the hint is the fact that it links, it's still part of question C. So it links with the other question. It says AD is equal to x over 2 sine theta. So taking our diagram so that we can see what we're doing, this time I need to use AD. So I need to use that line over there. I need the theta, so it does indicate that I'm going to be using that triangle. It's a right angle triangle. So let's have a look at what we've got. For a right angle triangle, we're looking for AD. We've got an expression for AB. We've just done that. So I'm going to use those two sides, which leads me to using tan theta is equal to my opposite side, which is AB, over my adjacent side, which is AD. I need to get AD on its own, so I have AD is equal to AB over tan theta. Now we've got two different expressions for AB that we've already worked out. We've got this expression for AB that we worked out in the last question, but we also have, from the previous question, we have another expression for AB. So now the trick is, which one of those am I going to use? Again, use your question as your hint. If you look in your question, we do not have betas in our question at all, and we definitely do not have an angle of theta plus beta. So it doesn't make sense to substitute that one in. So instead I'm going to substitute that one in, the one that we've just proven in the previous question. And I get AD is equal to x over 2 cos theta divided by tan theta. To work that out, I'm going to change the tan theta. Remember that tan theta is the same as sine theta over cos theta. Again, the hint that I'm doing that is because if I look at what I need to prove, it doesn't have a tan theta in it. So then I land up with AD equal to x over 2 cos theta. We tip in times. The cos thetas will divide out, and you get AD equal to x over 2 sine theta, which is what we needed to prove. I hope that has helped. Now please do the exercise, and best of luck.